All right, folks. Now we're going to move on to Unit 3, Part C, which talks about structures. Structures is a really important thing for Swift programming because it is kind of unique to the Swift programming language. There are other mechanisms that are similar to this in other programming languages, but the way they entitle it and the way they use it is a little bit different in Swift. So I'm going to go ahead and come into our student version. I got to make sure I'm in the student version. And we're going to open up the structures playground under 3.2 folder C. And so I'm opening up that. Of course, we have to trust it to open it. And I'm going to make sure I go back to the introductory page here so we cover all of the content. All right. The beginning here is kind of interesting, and it's has us consider a couple of different things, which is kind of giving you a framework for why we use this as a tool in Swift. And it says when building an app, one of the most important things to think about is how your app is going to represent the information that it needs, right? So we're starting to think about data, really, and data often is complicated. And I think that's really important to think about. Sometimes apps are software models of the real world. For example, a shopping app has products, shopping carts, customers, and orders, just like a real store does, right? So, and that's not by mistake, because those are concepts that we can latch onto in a tangible way. In general, the types of data that an app deals with are known collectively as its model, and sometimes more verbosely as its data model. And, you know, I think we maybe touched upon this real briefly last time we were together, where one pattern for programming apps is this approach we call model view controller, where we do what we call a separation of concerns in programming so that the data that we're using sits separately from the logic that we're processing it with and the view that the user gets of the whole app, right? And we kind of see that as we're building, graphical apps, that there's a graphical part, there's the logical part, and now we're kind of throwing in a more complicated structure than an array. An array is more complicated than a variable or a constant, and a structure is more complicated than an array, right? So we're kind of stepping up the complexity of the data structure. So when we look at the data as a structure, we think of it as a data model. And notice it says a model is specific to a particular app. A music player app might work with tracks, artists, albums, and playlists. You think of like your iPod or whatever. A drawing app might work with pens, brushes, a canvas, and shapes that the user has drawn. In this playground, you learn some ways of defining the model of an app, starting with the song. All right, so let's kind of look at this example. It says, you know about some types, strings, ints, doubles, booleans, but how can you use them to represent a song or a list of songs, right? You could try something like this. So for example, we have one array that's filled with song titles. So we got, ooh, yeah, maybe, no, 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 making up your mind. And then artists, you see the list of artists there. And then durations, meaning how long the song is in seconds. And then we have this thing, song 3, which seems to be pulling from each one of those arrays the third song, which is in position 2, right? So if we remember our index values, that would be, position 1, position 2, position 3, but the index values are 0, 1, and 2. So when we say song 3, we look at position index value 2 to find it. So we're pulling up the song title, the artist, and the duration of the song from our list, but it's the third song. And, if you want to see the sidebar output on this, right, you just pull it over. So is No, No, No by Fizz 150 seconds long. It seems like it if those arrays are correct. All right. So even though the information for that one particular song is stored across several different data structures, really, if you think about this, wouldn't it make sense to combine those data structures into one larger data structure that holds all that information, all three of those arrays? It would, absolutely. And we need to learn how to create that. In Swift, we call this a struct or a structure, and it's really an important thing. And it does raise some questions, right? So look at and see how that compares to what I just said. How would you loop through an array of songs? What if you wanted to pass a song as an argument to a function? And what if you decided you also wanted to include a star rating with each song, like reviews or something? Would you have to rewrite everything? You might, right? So it would be much better to have a song instead of a string, and a string and an int. So in other words, we're looking for higher level data abstraction here. So let's take a look at how we might do that. This is a really interesting correlation. So if you have, and I'm going to kind of make a comparison here to other languages, if you have learned how to code in a higher level language, and I'm thinking most notably a language like Java, which is an object-oriented language by default, where we in Java will define what we call a class. So the first correlation you're going to make here is like, this is kind of like a class in Java or other languages. Okay. And yes, indeed, there are correlations here, but there are some differences too. The first thing that we do is we use the keyword struct to represent structure. And it's, as it says up here, it's a simple way of grouping values together with a single name, right? We are setting up three constants inside here. And notice we are declaring its name and its data type. We are not giving it values as of yet. Could we? Yeah, we could actually do that, but we can also do it in the aftermath. So, and they use this word abstraction. It says, as a data abstraction, a struct provides some distance between the abstract properties of a data type and its concrete representation. And unlike arrays, which must contain components of the same type, structs can contain components of different types. So here's an opportunity that if I have some data about something that's a number and some data about something that's text, I can intermingle those and have both available, right? Because let's think about it. Often, that's how the real world is, right? Some things might have a verbal description, but also have a numerical value. So this creates a new type called song. And notice here, song starts with a capital letter. Correlation once again to Java, when we do a class structure, we start with a capital letter because then it indicates to us it is a higher level data type. And really what we're frankly doing here is we're creating our own custom complex data type. That's really what's happening when you stop and analyze it. Right. So you learned about properties in the instances lesson. Song has three properties: title, artist, and duration, each declared with a let and a type annotation, so we know that the data type, basically. You can think of a song as an abstraction that groups three constants, two strings, and an integer to represent a specific song with its own title, artist, and duration. It says your struct is a new type, and like all other types, and you notice they're making the comparison to strings and integers, its name should begin with a capital letter. Property names should begin with lowercase letters. So in other words, title, artist, and duration, since those are properties, all start with lowercase. The data, the structure itself starts with a capital S. All right. So once we've actually created the data type, and I want you to notice, we're not assigning any values to anything in this case, right? We are going to instantiate it or create an instance of song, and we'll set up a constant named song. And here's an example now where we're taking a complicated data structure and feeding it into what looks like a simple variable name. But the reality is that complexity that we see above, right, with the whole structure, it carries with it. And you'll notice that when we are constructing it, we call the structure itself with the capital S, and then we feed in the information it's expecting. So we use the property title, that's a string. Then we use the property artist, also a string. Then we use the property duration, which is a numeric value for the number of seconds of the song. So now by doing this, we have now created a new instance of a song with its own unique name based on the structure listed above. I want you to notice that the definition of the structure contains no data. It just contains the pattern for the data. It's not telling you what information is going in. It's just telling you, well, if you have a song, it's going to have a title, an artist, and a duration. That's all it's telling you. When I create an instance of it, that will be unique unto itself. And, I kind of wish they would use like song 1 or something like that. You could, of course, repeat this, and they're actually asking you to do that. So it says, try creating a new song. So let's do that. I'm going to say, let new song equal, and then I'm using the song structure, right? So there's the first parentheses. Then we're going to type in title. And notice how it auto populates all that once I get the first piece in. And I'm just going to create whatever, yeah, that's my song, whatever. And that should probably be a capital W. And maybe this is a blues song, whatever blues. The artist is, I don't know, give me a blues artist.
BB King.
There we go, BB. That was the first one that popped into my mind too. So we must be on the same blues wavelength. And the duration is, I don't know, 234 seconds. Still throwing a little bit of an error message here. I'm not really sure why. I don't think I made any mistakes. Oh, God bless you.
Thank you.
I really am not sure what that error message means.
Yeah, neither do I.
Are you guys getting the same error message?
Same error, yeah.
Yeah.
Yeah, that I am finding that a little bit unusual. I did move down to the next line and it went away eventually.
Oh, it did for me too.
Just took a while. And I think maybe part of that is because it's a little more complicated. All right, let's move on to the next screen. But that, now we have created that. Now, if you wanted, and I'm just going to put it out there, you could try printing new song, and let's see what the output would be. All right. Okay, so it shows that it's retained, and for that matter, if you want to print out the other song, you could do print song, the lowercase song.
So is this basically like creating objects, like you would in JavaScript?
Yeah,
Or,
it is, right? Because and I think you're seeing the correlation. That's the same correlation I made initially, is it's kind of like you have the definition of like a JSON object, right?
Mhm.
And then this is kind of like populating the individual components. Yeah, very, very high correlation there. But at the same time, it's also unique in format, to this language, right?
Yeah.
And it has some different aspects to it that aren't available in JSON objects or class structures in Java. The other thing that I found really curious and that was perplexing me when I learned it is I was like, how does this make sense? But think about it. If I create a song by an artist with a certain duration, when it's created, those are going to be constants. The song name isn't going to change. The song artist
Mhm.
isn't going to change, and the duration's not going to change. So this is showing you the pattern for creating it. The pattern could include variables, right?
Interesting.
So, I mean, like if you had if you were doing like a data model on a person, you could say current age, right? And that might be a calculated value. That's a variable, right? Because that will change every year, right? Or
Mm.
if you see what I mean, right?
Yeah, yeah.
So let's move on to the next page. All right. So now that we kind of have this in place, now we start to look at these song things as structures and how we can access the properties. Now, if you remember from our previous playground, a property follows the name of an object that fits into a certain category, and we just use dot syntax to access the property with no parentheses. And that's what's happening here. So here's the structure, same one we had on the previous page, same song that was defined. And then to access those properties, we can just say song, lowercase song, meaning, you know, it's a unique instance, the title for it, the artist, and the duration, meaning that once the object is created in memory, we can access any of its properties dynamically. So maybe I don't need to know the artist, maybe I just need the title. Or maybe I don't need the title or artist, I just need the duration. How long is this song? You know, you can ask that specific question and extract the information directly from the object, right? The properties on the instance you've created called song, right? The instance has a specific title, type song does not. The generic format doesn't have that, but it has the structure for it, right? So, and you can think of it this way. It says the description of a cat, such as a cat has 4 legs, whiskers, and a tail, cannot be changed, right? But you can, it cannot be stroked, but you can stroke an actual cat if it's in the right mood. I think that's a really bad example. But whenever we do this, right, we are actually creating a song. When we look at this is just the archetype for a song. You know, when I teach class programming, objects and classes, I usually think of it as a blueprint, right? Like, for example, I can have the blueprint for a house, and as developers often do, like if they build like all the houses in the subdivision, they might be working from the same blueprint, and then you just make alterations like different color siding, different roof, more windows, or you know, whatever the case may be. So here's our experiment. Uncomment the line below and look at the error, right? And you want to notice with this that it's got the capital S, right? And notice it says error, instance member title cannot be used on type song. Did you mean to use a value of this type instead? You know, so they're telling you you can't look at this because this is the blueprint. This is, you know, this is on paper. This isn't an actual house yet. You know, this is the concept of a song, not an actual song. So I'm putting the comments back, by the way, because we don't want that error. All right, let's go to the data abstraction page. Like any form of data abstraction, structs simplify the code that works with related data. In the case of a song struct, you no longer have to worry about 3 parallel arrays. Using the data abstraction can result in a program that is easier to develop and maintain. And this is the same reason why we see this in all the other object-oriented languages, by the way. It is much, much simpler to like interact with complicated objects that way that have a lot of data points. Much, much better. All right, so here's the exercise. It says, complete the missing code to process the parallel arrays from the first page of the playground. So they're repeating, you know, the code here for you. And what they're asking us to do is this, you know, return a string describing the song, and they have an example given. So like maybe by Brenda and the Del chords, duration 200 seconds. So they're asking us to build this, right? So that's our challenge. And then what would happen here is our task is to figure out how to do this using this technique. And then we're going to compare it to doing it with the structure technique so we can learn that it is significantly easier with the structure to deal with a complex data type. All right, so if you want, you can go ahead and you can do what I'm going to do, which is I'm going to pull up the teacher version here on the other screen, right? You guys are like, oh, you're cheating. Yeah, I don't think of it like that. I think of it as teaching you effectively. Um, and just so I have a little bit of a guide on my own here. And we are on the data abstraction page. And I just want to make it go as efficiently as possible. I'm going to leave all those comments in place. And so the return is going to look like this. So we want to include a quotation. So I'm going to backslash quote. And then I'm going to put in the another backslash here because I want to insert the title. And then I do want to put in a closing quote. So in other words, I'm putting the title inside of quotes is what's happening here, if you're wondering. And then by, and then we're going to put in the artist. Then we'll list the duration. Spelled correctly though. And this is a verbal description. And then here is the string interpolation. So we type in duration. And then seconds. And I think that should fix my errors. And it's saying can't find artist. Oh, because it's artists, plural, right?
Oh, yeah.
No. That's not.
No, you're correct.
All right. So here's, okay. So I'm missing a really important piece here because I'm not writing the parameters yet. So I got to put the parameters in. No wonder it's not working. Right. So I was waiting for all this like brilliant autocomplete and none of it was happening. So what are we passing in? We're going to pass in the title, which is a string. Then we're going to pass in the artist, so a string. And then we'll also pass in the duration. Right. This is all going to return a string. So now, hopefully that message goes away. And this will loop, right? So, no, not loop. This is just a function. So now I got to call it. And what I'm doing here is we wrote a loop that's going to loop through all the song titles, right? And then it's going to extract the song title from a certain position, the artist from a certain position, and the duration from a certain position. And excuse me, if you look at the console at the bottom, you can see the output, right? It's printing it right to the console. All right. Not, I'm going to say, I guess, not that difficult to do, really, but very verbose, and but it does work, right? And there's kind of another issue with this is it's possible, like if I was messing with this, what if I added a song title and then forgot to add the artist, or maybe I forgot to add the duration and now my arrays aren't the same size, that could pose a problem. So a little harder to read this code, and definitely maybe a pain to maintain as well, especially if your data structures change, right? Because we're dealing with three separate data structures, three separate arrays. All right. So the next thing that they want us to do then is use a structure instead, with the same approach that we had on the previous page. Now, what they like us to do is follow these prompts here to first create the array of songs. And so basically what we're going to do is we're going to create an entire array of structures. You guys following me on this? Right. This is kind of fun, right? So this is where it does, Jonathan, you were talking about like comparing to like JavaScript objects. This is very similar, very, very similar. So I'm going to have create a constant called songs plural, right? I'm setting up some square brackets here, and then I'm spreading them apart, because inside here now, I'm going to instantiate a bunch of songs. Capital S, and then we're gonna follow the prompt here. This happens automatically, right? So I'm gonna come up with a bunch of names. So let's, um, we were playing with songs we like, right? So feel free to use whatever artists and songs you'd like. I don't know the length of these songs, but I'm gonna come up with something, you know. And really, we don't want to put a string in there. We want to put a number. So let's do like 480. Now, to separate these inside the structure, I'm going to use a comma at the end of each line. And then I'm going to repeat. I'm just going to say song. I'm going to pull in that whole structure. Right? So you guys saw how I did that with the IntelliSense, and then just start typing. Type it right though. Two L's, yeah, two L's, Metallica. I have to actually think about that. That's kind of funny. I'm not sure how long the song is, so the durations are highly speculative, but what they'd like you to do is create at least 4 songs.
I'm having issues with Xcode right now. I can't, every time I bring up Xcode, it immediately goes, it freezes up and it's non-responsive.
Okay, do you maybe have a secondary instance of it running?
How would you check that?
You could do a force quit and see if it pops up on that list. Or if you have maybe
I've been having to force quit to even get this to close to begin with, and
you didn't see multiple versions of it listed.
no.
Try right clicking or command clicking on Xcode down in your dock, and see if you have other playgrounds open that maybe you're not considering. Otherwise, the unfortunate thing is you might have to restart. I'm hoping that's not the case.
Wait, you said the check on your dock.
Yeah,
How
like
did you
if
do
you're
that?
looking at my screen right now, I'm like right
Mhm.
clicking, and this shows all the stuff that's currently open right down here.
Okay, yeah. So I only have data abstraction open right now.
Okay. Yeah, I'm gonna say restart Xcode, but you've done that how many times?
At least 10.
Okay. Jonathan,
It's
I think
it's
the wise play here is to just go ahead and restart your machine.
yeah, it's working right now, but if it does it one more time, I'm gonna restart my machine.
Yeah, and actually maybe a little bit less destructive and quicker it would be to just log off, like shut down all your programs, log off, and then come back. Log
Yeah.
back in rather than reboot. I'll let you kind of manage that. So if you disappear, I'll understand.
Yeah, thank you.
All right, I'm going to do one more song here. And of course, I always struggle with like which songs to choose. So I always go back to my standard like 4 or 5 that I always use for all my programming. Why think about it, right?
Right.
So I created my list of songs here. And actually, technically, this is an array of songs, right? With songs being a complicated structure. That's kind of interesting. This is maybe one of our first examples of storing really complicated objects, by the way. The next thing that they want us to do here is to declare the song information function here, but this time we're going to use properties. So in other words, what we're going to do is we're going to basically repeat this approach, but not using the previous syntax, for getting to this information. We're going to have a more efficient function, and you'll notice very, very similar to what we did before. And I'm going to do this in a couple of ways. So I'm going to have to be really careful about the names I choose here. So I'm going to say information or, right? Meaning the information for the song. I'm going to need to pass in some parameters. And what I will start with is first, I'm going to use the underscore. Remember, that means whatever I throw in here is what that means. And it is internally, we're going to call it song, and it is of type song. And this is where it gets weird, right? Because normally, what would you put here? String, int, whatever. But now we created a structure called song, and we can use it like a data type. So really, truly, what we're doing is we're creating an abstract data type that we invented, and now we're using that data type in our code like we use any other data type. And it tells you something about data types because they are constructed, right, in the language. Ultimately, this will return a string. So let's type that in too, and then set up our queries. Now we're just going to do our return statement. And rather than fumble with this too much, I am copying from the author's solution, but he is trying to maintain basically having like an output that's got quotations in it, so you'll see this syntax. I'm going to start with double quotes, and then I'm going to go inside here. This is a little bit different than how I did it last time. And then I'm going to do backslash double quote, and then put in string interpolation for song title or song dot title. And you see how the IntelliSense already is reading into the object and pulling back its properties. And then we're going to backslash quote here because we want the double quote to appear around the song by space. Then we're going to put in the artist here. So, and oh wait, we're pulling that from the song dot artist. And then putting in a comma. The duration is slash song dot duration, and then seconds. So we're trying to mimic, basically the output from before, but look at the syntax difference on this, and I think it's significantly interesting, right? Because we're, and this is hard to see all at the same time, but we're trying to compare this line, right, with this. What's unique about this is we're referring to one individual song, where with the other one, we're referring to an individual array. Still pulling back the same info, in essence, but a little bit cleaner, I think. And it is correctly attached to the array. Now, if we are to loop here to see what we have to call the function, right? So we're going to say for song in songs, right? So the singular song inside the complex song array that we created up here. We're going to loop through all of those. We are just very simply going to print out the information for the song, and which song, well, whatever song we're processing right now. So there's your completed syntax. And then sometimes you have to press enter and move past the code in order for it to work. Now, the first two things down here in the console, or the first few things here in the console, are from the previous code up above. Here is the code that I just typed up, and you see how it also pulls it in. Look how much simpler that print statement is. This is really complicated, right? Look at how simple my call is, because the complication is in the structure as opposed to being in the code. So structures, when they're set up right, and you have a really nice data model for whatever you're abstracting, whatever thing you're thinking of building, results in super easy code when we type it up, because all that information carries with it in the structure. So the call to pull the information back is very simplistic, and in my mind, a lot easier to understand once you understand what's going on underneath the hood. You guys all good?
Yeah,
Okay.
I did have an issue, but I figured it out. I forgot the commas.
Yeah, that makes an issue. Yes.
Yeah.
Commas are important. So like here, because we do have multiple objects, really, you know, if you think about how we do arrays, right? Like we do a thing, a comma, a thing, a comma, and when it all fits on one line, great. But with these being complicated objects, we're still inside the same structure. It's square brackets, and we are separating by using commas, but because they're more verbose, we just put each on its own line. That's pretty common actually when you're writing code in this style.
Okay.
Let's move on to the next one, mutability. Right, it says recall that an array declared with let is immutable, right? Meaning we can't change it. Where one declared with var can be changed and is therefore called mutable, right? An array is a kind of struct that you can make your own structs mutable or immutable. And this is kind of what I was mentioning before, that you can have stuff in a structure that is fixed and stuff that can change. And what they're showing you here is that the name, the artist, and the duration of the song is always going to be what it is because it just is, right? It's a given. But people reviewing it and rating it, well, somebody might give it 5 stars, somebody might give it 1 star, whatever happens, and that can change, right? So sometimes people might like it a lot, and sometimes people might not like it at all. Somebody new hears the song, they rate it differently than somebody old that hears the song. Like who knows, right? But you can include things in there that change. So in this case, we're going to instantiate a song, right? Call it song again, same one. We're just adding a fourth property to it called rating and setting it to 0, right? So if I output song rating here, I see it's 0. Then I give it a value. And then when I output it again, I see that value. But notice what happened here. Like when we set the value in the playground sidebar, it doesn't have the number 4. It's just telling you it's getting added to this structure is what it's. So if I want to see that property's value for this particular song, that's why we do this, right? All right, so now they're saying change the variable song to be a constant. What error does that produce? So let's switch this to a let, and let's watch the errors fly. Right? Sometimes you break stuff intentionally, and on line 24, then when I try to look at or assign a value to that property, I can't do it because it's a constant. So when I create a song that has, and this is the takeaway here, when I create a song that's built on this structure and part of that structure is variable, I need to create it as a variable so that I can change the variable entity within it. You guys seeing what I mean? Whereas if this was a let and it was locked in, then I could use let here because nothing inside here can change. As long as something inside the struct can change, then we have to use variable here if we intend on changing any of its stuff inside. All right. Now, this is kind of interesting too, because like a class structure, like if you're doing the comparison once again to Java, when we like press forward on, we might assign data properties to an object, but we also have what we call methods that are built in. And so look at what it says here. It says a song has a duration property measured in seconds, but it would also be useful to ask a song for its duration as a string formatted in minutes and seconds. So in other words, like, okay, when I look at seconds for a song, that's not how I think about it. I think of it like 3 minutes and 10 seconds, So what they're going to do here is they're going to take and build in a variable structure inside here that will take whatever the duration is set to as a number and it will process it. So we will have a variable that will basically be a string that will do a calculation and then return this thing. So this becomes a computed property. So we still will access it like a property, like all the others, but there's math going on in the background. So in other words, if I set up my song and I say, you know, it's 200 and, or let's just look at this one, 150 seconds long, right? This property, if we ask for it, and that's the really important part, we'll do the math and it will take the duration divided by 60, which gives you the minutes. And then you take the duration mod by 60, which gives you the remainder. So you know how many seconds are left over. And then you can output, you know, X number of minutes, X number of seconds, right? So if you look at the example, if we look at the computed property here, 2 minutes, 30 seconds. Pretty useful, I think, right? Because sometimes the raw information doesn't really give you necessarily what you're looking for in terms of output on the screen. And because this is kind of a standard thing to do, it makes a lot of sense to add it to the structure because a lot of people are going to want to think of it this way. Nobody wants to go, oh, it's a 150-second song. 150-second song doesn't make any sense. 2 minutes and 30 seconds does make sense to me. And this is just simply a property that has more programming steps inside of it. And it's in the format of a string. So ultimately that's what's being stored, but it is also variable, right? Because it's being computed, right? So if I let a song equal this, and notice we're not adding an additional property to feed in, that's being calculated by the 3 that I'm putting in. Actually, it's being calculated by one of them, but I can call upon that property that's calculated and output it and utilize it. So this is an example of using an internal piece of information and then taking that piece of information, doing a little math with it and coming up with some additional meaning or value, right, to it. This is what we call a computed property. That's pretty normal. Now, it says you've already encountered a computed property, the count of an array, right? So we already played with that, right? So we, whatever our array name is, dot count. And it's declared as a var since it could change depending on the rest of the structure. The rest of the declaration consists of a name, a type annotation, and then some code and braces, which then returns the value of the correct type depending on what you're asking it to be, right? And that, a lot of that is a logical thing that you'll determine. Note that inside the definition of formatted duration, the property duration is accessed without dot notation. And the why is because it's internal to the structure. It's already implicit that you're dealing with this particular object. So like, you know, when you do the call, which song? Well, this song, the duration of this song, not no other song, just this one, right? So we don't need to use the dot internally. So in other words, I don't have to say here song dot duration. It just automatically realizes that it's attached to this property. It's internal, right? It says, note that the definition inside a formatted duration is accessed without dot notation. Within the code of a struct, you can access its own properties directly by their names without the dot. So if I wanted, for example, I could also access title and artist without dot notation, as long as it's inside the structure. So here's an exercise. Add another computed property to song named formatted title, which gives you a string for the song above. The formatted title would be No, No, No by Fizz. So let's see if we can do that. So I'm going to come up here and start creating that. And we'll call that a var because it could change, right? Or it is going to be changing information. They want us to call it formatted title. And it will be of data type string once again, because we're going to output a string. And how are we going to do this? We're going to say, let, what stuff are we going to put in there?
So we need to get the artist, we need to get the title and the artist and and interpolate it into one string.
Yeah, I mean, that makes a lot of sense. It's actually pretty simple when you stop and analyze. We're just gonna go directly to returning. There's nothing else to really do. So I'm gonna grab the title of the song, right? A space. We'll say the word by, a space, and then the artist. And notice how I'm pulling in the properties automatically. Swift knows that it can do that since I'm inside the structure. We just go right to it. Then, of course, if I want to see that, I would just say song dot formatted title. You will see in the sidebar now, no by Fizz. And that's exactly what we were tasked to do. I'm gonna try to keep that all in view there. So let's see if I can do that. There we go. All right. Computed properties are a further example of the power of structs to create data abstraction. Instead of using separate functions outside of the struct, you can put related functionality right alongside the data it relies on. And this is really, to me, the useful part of it. So like if somebody says like, you know, what's that song and who's it by? You can just simply call the formatted title, and then it gives you both pieces of information, right? So it's just a matter of design. It makes sense for it to be internal because it's directly related to the stuff inside there. Why would you write an external function to call into something else to pull out the information? Makes no sense. So this is one of those things that is really, really useful in programming, by the way. Right. The other thing is, when you write it really well, right, and I say song formatted title, it also gives us that black box effect is the point that they're making, that we don't need to see how the motor works, right, in order to drive the car once again, but we can drive the car. It says re-implement the song information function from page 4 as a computed property. It can rely on the other computed properties to do its work. It says, imagine how these would have looked like. So now I'm trying to recall what page 4 looked like. Oh, I see. Right. So we just want the information where we're showing the title, artist, and song. And they want us to do it a little bit more efficiently. And I'll show you the efficiency here. And this is where it gets kind of cool, I think. So like we are going down the rabbit hole using the Alice thing a little, maybe too much. But now if we just want song information, I can come up with another property just called information, which will be a string. And if I was to rewrite that statement, right, think about this. I can just do a return. And what am I returning? Well, I can return the formatted title. It's already set up. I don't have to type anything else. It's already done, right? No string interpolation or anything. And then I will throw in, you know, the formatted duration. I probably will put a little text in here. I guess I could do comma space duration would be a good fit. And then just concatenate onto the end of it formatted duration, since I already did that too, right? And so it makes it really clean and simple. And then if I want to just get the song information, I just say song information. Here comes all the information with one statement real efficiently. And okay, so it looks like I need to put a space here, right? Make it look better. But there's all that information, and look how simple the statement is. And then when you're calling it externally, oh my God, is that simple, right?
Mm-hmm.
Do I care how it works in the background? No,
No.
not at all. So I think that's pretty cool. All right, let's keep plowing forward here, folks. All right. Now, so far, we've looked at properties, and we've started to figure out that we can use computed properties and combine things and get really clever with it so that our syntax externally is really simple. But there's also this possibility, for example, if I wanted to take a structure, in this case, this is like a rectangle, right? And what makes a rectangle a rectangle? Well, the first thing we know is it's got all of its corners are 90 degrees. And then two of the sides are one size and the other two sides are the other size, and they're the same, right? So there's a width and a height. There's basically two measurements to a rectangle. And it says if you wanted to find out if one rectangle is larger than another, you could define a function like this, right? So is rectangle, right? And then we're feeding in a rectangle object width and height, right? And look at the syntax here. And this is where Swift starts to get kind of cool. We use a blank here, meaning we can feed any rectangle in under any name. So the function reads like function is rectangle bigger than rectangle 2. So rectangle 1, rectangle 2, and then it's going to be a true or false response. And then what we're basically doing is we're feeding in a rectangle with its height and width. We're using its properties to do the math, right? So we're just saying rectangle height times rectangle width, rectangle 2 height times width. Those are stored. And then we're just checking to see is the first one bigger than the second one, and it's going to return true or false. I would have been more comfortable with this example if it was rectangle 1 like this in terms of like the consistency, right? I think it'd be easier to read is rectangle 1 bigger than rectangle 2. But here's one of the things that they've always tried to do with Swift when they designed this language is that you could have code that you could kind of read through like that, and it just makes sense as an English sentence. Like, wow, okay, that's pretty impressive, actually, that they managed to find a way to accomplish that. Part of that is by using this kind of blank thing too, right? But this is just kind of the approach, folks, right? So bigger than, remember, is kind of a generic placeholder name for internal variables that we're feeding in. Now, if we're going to call it, right, right, so we can say let rectangle, and of course I broke all the code right here. Will this still work though? Well, it is working because I'm still getting sidebar output. It doesn't matter what's happening internally. So we're going to create a new rectangle externally now. And when we create it, we have to feed the properties in of width and height. And so that stores here. Then we have another rectangle, same thing. We see it's a little bit taller than the other. And then we check, is the first rectangle bigger than the second rectangle? And notice once again, the syntax is rectangle bigger than, is rectangle bigger than another rectangle? And if it makes more sense to you, you could say, this rectangle, etc. But you don't have to necessarily change that to make it super readable, as long as you can follow the logic of it. Right now, they're making a point. Here's the point. This works, but there's a couple of issues. 2 arguments to the function are a lot of code to read in one line, which makes it harder to understand. The function is available everywhere in a program, but you only need it when dealing with rectangles. So guess what we're going to do? We're going to move that to the inside of the structure. So if you don't know where that function is, it's going to be hard to locate it and and to write the code for it. So here's what makes sense. We're going to take that function now and put it inside the structure, right? And notice we use the same syntax basically, but a little more streamlined. Both of the rectangles will, all the rectangles that we create will have width and height. Those are givens, right? The function though is going to return that Boolean once again, is bigger than, and then we're going to compare. And what we're going to basically be feeding in is, the width and the height, which are properties, so we can refer to them directly. And then we will have a secondary object. And notice here we are calling a property of a different rectangle, which we're going to feed in. So what we're going to feed in, so we'll have one rectangle already created, and then we'll have a second one, which we feed in to this function, and then it compares and says, no, that one's not bigger, or that one is bigger, look at the simplicity here of the call to this, right? Instead of that complicated syntax we had before, we still have to create a couple of rectangles. Okay, so those are created. Now we can just simply say rectangle is bigger than, and all you have to feed in here is the other rectangle. Compare that to the previous page. Much simpler syntax, right? Same thing happens here if I want to do it in the other order, is the other rectangle is bigger than the rectangle I'm feeding in. Now, the other rectangle is bigger, right? So other rectangle is bigger than the rectangle I'm feeding in, true. Do it in the other order, false. But I really like this approach. Now, because this is a function, right? It does have the parentheses that follow because we still have to feed stuff into it. We, you know, and in truth be told, you may or may not feed stuff into it, but in this case, we must. The generic placeholder here allows us to feed in whatever the object name is, by the way. Now they're asking us now to simplify this declaration, right? So give me a second here to get caught up on the teacher side. Like way behind on the teacher side. I must have been actually understanding it or something. All right, so here we are on the same spot. And the first task is simplify the is bigger than method by creating a computed property named area for the rectangle and then using the computed property inside the is bigger than method. So in other words, don't do the math like this, you know, let's turn this into a computed property in these spots to handle that for us. Okay, so here's how we're going to accomplish that. We're going to add a computed property, so that's going to be a variable, and we're just going to call it area because that's what it is, right? We're working with integers here, so we'll stick with integers. And then how do you compute the area? Well, we're just going to take and return the width times the height. Simple as heck, right? This is a really simple formula. So, and this is a computed property. All right. Now, to test this, do we need to change anything else that we're doing? Well, the answer is yes, because now we have to switch this up here. We're still going to feed the same information and we're going to feed in an external rectangle. But now, instead of calculating one, calculating the other, and then comparing the two, I don't need to do that anymore. All I can actually get rid of these two lines. I'm going to comment them out instead of deleting them, right? To show you that we're replacing them. And I'm not working with these two variables anymore. And the variables that I will be working with, and not variables at this point, by the way, is they are going to be basically taking the internal data structure, right? And replacing this with simply area, which is a property, is the area greater than the area of the rectangle we're feeding in. So the rectangle we're feeding in and its property of area, because it also is traveling with the same property. So I'm just comparing one property to another. See how much more streamlined that is? Way better. All right, I'll delete these two lines, by the way. All right. All right. So that was this exercise. And I'm just going to say, see above, right? See above. Now, the next challenge, and I'm kind of looking at the time here, and I think we'll do this and we'll call it, right? And this isn't finishing as much earlier like I had hoped, but hey, whatever. That's how it goes some days. We have the challenge now. It says for further practice, extend the song struct below by adding a is longer than method that you can paste your code from page 6 as a starting point, and then use a loop to find the longest song in the array and print it to the console. Hint, use a variable to keep track of the longest song and initialize it to the first one in the array. So they're giving you a tip here. And so I'm going to do a little bit of borrowing here. So because I do want to speed this up, because this code exists on the previous pages. So I'm not getting it from nowhere, but I'm pulling it from the instructor's solution, by the way. So we have all the standard struct things at the top, and then we are going to add the formatted duration. In the chat, by the way.
Oh, thank you.
We also did, if you remember, the formatted title and the song information. So there's no need to recreate this stuff because we already have it, right? So that's kind of the point. So just the same as going to the previous pages and copy pasting it. I'm just doing it from its separate screen. Then they wanted us to create a function to go with, right? And the function, I'm just going to drop this in the sake of time efficiency, by the way. Here's the entire function. So this one you probably want to type in. And by the way, actually don't type it in. Here's all three in the chat again. So since this isn't formally an exercise, it's just practice, right? So what this function does is it will receive a different song, look at the duration of the current song compared to the duration of the other song, and then return true or false. And it's all built right into the object. We already have a list of songs here. Now we need to find a way to call these. So here's how we'll do that. First, we're going to set up a variable of a song array. Okay. And then we're going to set up a loop. And don't worry, you guys, I am going to paste this into the chat here in just a second, by the way. So there's my loop. So if the song in songs is longer than, then we're going to say the longest song equals the current song. So what it's going to do is it's going to step through all the songs. It's going to take the first song and automatically put it in this variable as the longest song. Because when we first process it, that is the longest song, right? Then when we do the loop, we're going to check to see if the next song is longer. And if it is, then that one gets stored in longest song. And we keep going until we've processed all of them. Then we'll print the longest song. And the longest song should be Making Up Your Mind by Boom, right? Which it is. So there's the example. So here's what we're going to do. We're going to take a look really quick at what we learned. All right, so you guys can read through here. But basically, we've learned that a structure is a complicated, self-created data type or data abstraction that can hold a lot of complex data of various types. It can also have properties that we can access directly, properties that are calculated, and then we can also add functions to do processing, and that all the internal properties can be self-referenced internally, and it makes our coding a lot easier externally. And it also results in front-end code that's easier to read. And that's really important, ultimately. Now, the challenge exercise, by the way, is to complete this little exercise here, which is to create your own structure. And I'm going to do this like we did the ones coming into this week. I'm not going to answer it right now. We'll answer it next week when we get back together, but I would appreciate if you guys maybe took a little bit of time. And okay, here's the thing, like when, maybe right now is a good time to do it, right?
Yeah.
While the stuff is fresh in your head, rather than like wait a few days or hours or weeks or whatever, and then go, oh my God, what was this all about? I forgot, right? Probably easier to do it now. So the way that they want you to do it is it's kind of a multi-step process. So this is a little bit longer than you might think it is, by the way, but not that long. Okay, so take your time with this one. When we come back next time, we'll look at the solution to this, which I'll independently record and post after the fact. So this recording will stop here. Here I'm hitting the stop button. So sayonara.